This is Mike McCown with Wildcat Solutions. We're a systems integration company that has a field service group that helps people with their maintenance issues. Today, we're going to talk about maintenance strategies. So, if you have any comments or suggestions or questions, please add them in the section below. This will be a two-part video. The first part will talk about cost of downtime, the causes of downtime, what information do you need to track to make good maintenance decisions. Then the second section will talk about the different types of maintenance: reactive maintenance, corrective maintenance, predictive maintenance, and then we'll do a comparison of the different types of maintenance. The 2014 Gardner study suggested that unscheduled downtime costs as much as $5,600 a minute, while the 2014 Avea study suggested the range was $2,300 to $9,000 a minute. Many things go into figuring out what your cost of downtime is, and unscheduled downtime is critical that you understand what those costs are. They include things such as idle employees, loss of production, startup costs, even reputation can be affected by it. A good example of reputation is when United Airlines dragged that customer off a plane. It was estimated it cost United up to $1.4 billion in lost stock price. Today, ExxonMobil has added reputation to their risk analysis ever since the Exxon Valdez incident in Alaska. The most common causes of unscheduled downtime are aging equipment, mechanical failure, operator error, lack of maintenance, and poor equipment design. When looking at aging equipment, you need to consider the life cycle of that equipment. Has the manufacturer ended, or are they going to end soon? The support for that. If so, you need to have a plan to either upgrade or replace that equipment. Poor design is another place that can easily be corrected. For instance, we encountered a water-cooled drive system that the pump starter had failed within the first year. After reviewing that starter, it was sized right at the top of the rating of the starter. We replaced that starter with just one size larger, and that eliminated the issue of the starter failing. Another good example are heater circuits. Quite often with heater circuits, the contactors pick up and drop out frequently. By adding a time delay in there to keep them picked up or dropped out for a certain period of time can increase the life of those contactors. Tracking the reasons that you have downtime. P2 performed a study of 20 oil companies and found 10 of those companies only had two categories for downtime. 6 of the companies had detailed categories, and only one company separated out scheduled and unscheduled downtime. 8 companies had more than 25% downtime hours attributed to miscellaneous categories. 2 companies had 50% in miscellaneous categories. One company operating 800 wells had 86% of the downtime uncategorized. They associated with deferred production over 3 months of 75,000 barrels of oil and 523,000 MCF of gas. These type of categories do not help you making decisions on how to reduce your unscheduled downtime. You need lots more detail. ISO 14224. This is a standard of best practices for collection of reliability data and maintenance data, which allows you to be able to share this information easily within the company, with contractors, or even with companies outside your company. We'll examine the failure data. In order to make good decisions about maintenance, there's a certain amount of information you should have, such as the location of that equipment. When did the failure occur? What was that failure mode? How did that failure impact safety, personnel, environment, and assets? How did that failure affect production? What was the equipment function that failed? What was the failure mechanism? What was the cause of the failure? What subunit failed? These are all pieces of information that you need to make a determination of how you can prevent this type of failure from happening in the future. Let alone if you have to have six pieces of the identical equipment and you have a failure on one, you can fix it on the others without waiting for those individual units to determine that same failure, which can be a cost savings in itself. This is the end of this video. When we come back, we will start talking about the types of maintenance.